So the first classification that we saw about hydrocarbons was the straight chain hydrocarbons. Do you remember? If you turn back your notes and see, that was straight chain wherein there is no what do you call that as like there are no extra carbon atoms, all of them are arranged in a straight chain. The next classification of alkanes is a branched chain alkanes. So in general, alkanes do not have all the carbon atoms arranged in a linear fashion. There can be branches also. So instead of carbon atom bonding with two other carbon atoms, it can also bond with 3 or 4 carbon atoms. So in that case, you will have a branched chain alkane. When a carbon atom bonds with 2 carbon atoms, it will form a straight chain. But if it bonds with more than 2 carbon atoms, that is 3 or 4, it will result in a branched chain. So for example, you have an alkane with 3 carbon atoms. What is this called?
Should be propane.
Methane, ethane, propane. Okay, so this is propane, and I have H at the extremes. Now this carbon atom, the carbon atom on the extreme is bonded to one carbon atom, right? The extreme carbon atoms are always bonded to one carbon atom. What about the carbon atom in the middle? To how many carbon atoms is it bonded? The one in the middle.
2.
2. So if it is just bonded with 2, you will have a straight chain alkane. But if it is bonded with another carbon atom which has hydrogen atoms attached to it, then you call that as a branched chain alkane. Okay, so instead of a carbon atom bonding with at the maximum 2 carbon atoms, they can also bond with 4 other carbon atoms, 3 or 4. So in that case, you get a branched chain alkane.
Alright.
Okay, so instead of in the place of hydrogen, you will have another carbon atom that is getting attached. That's all.
Alright, 1 second.
Okay. Another example would be like this: CH3, C, 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 C. This is also possible. Alright?
Alright, 1 second. Yep. Alright.
Okay.
Yeah.
So you see in this the second example that I gave you, you have 4 carbon atoms, and the second carbon atom is bonded to 3 carbon atoms, one here and one here. So this is a branched chain. So you see branches, not all of them are arranged in a straight line. Okay.
Yeah.
So the longest continuous carbon chain of a branched chain hydrocarbon is called as a parent alkane. So you will find out what is the total number of carbon atoms in the longest chain. So if you take the example 3, the second example, which one is the longest chain? This is 1, 2, 3, 4. Just naming the carbon atoms so that you can tell me which is the longest chain. 5, 6, 7. Longest chain means the one containing the largest number of carbon atoms. So is it the chain 1, 2, 3, 4, or it is 1, 2, 5, 6, 7? Which one is the longest chain? You have one chain wherein there are 4 carbon atoms attached, and there is a branch here. Okay, you can visualize. This is one way of visualizing. Alright. The other way of visualizing is you have one chain here, the second carbon atom, the fifth one, sixth one, and seventh one. Combinedly, you get another long chain. So, which one is the longest chain among the two? Is it the one containing 4 carbon atoms or the one containing 5 carbon atoms?
5.
Yeah. So, it is this chain, that is 1, 2, 5, 6, 7. That is the longest chain of carbon atoms, and that is called as the parent alkane.
Okay, I see.
You can visualize it in that way also. You can visualize that this is the parent chain and this is the side chain attached to the parent chain.
Mm-hmm.
Alright?
Yeah.
Yeah. Okay. So, to the parent alkane, you will have a group or a single atom or a group of atoms that are attached. So, an atom or a group of atoms that takes the place of the hydrogen atom on the parent hydrocarbon is called as the substituent group.
Mm-hmm.
Okay, so in the first case, you have 3 carbon atoms, 1, 2 and 3. And in the second carbon atom, the place of hydrogen is taken by the CH3 groups. Okay, so CH3s are called as the substituent groups.
Mm.
You are substituting hydrogen with a different group. Alright, in a straight chain alkane, it was hydrogen, but in a branch chain alkane, it is a group other than hydrogen. So that group which substitutes hydrogen is called as a substituent group.
Alright.
Okay. So if you look at this propane, the example that I just showed you, propane is the parent alkane, and in place of hydrogen in the second carbon atom, you have another CH3 that is attached. So since this is a carbon skeleton, which means that there is H3 attached here. Okay.
Yeah.
Yeah. So
Yeah.
this particular group is called as the substituent. Likewise, you have another molecule which is the hexane. So the longest chain contains 6 atoms, 1, 2, 3, 4, 5 and 6. So that is hexane, and you have 3 groups that are attached to 3 carbon atoms in the parent alkane. So the 3 groups occur at 3 different positions. One is attached to the second carbon, the next one is attached to the third, and the next one is attached to the fourth carbon. So all these groups that take the place of hydrogen are called as substituents.
Alright.
Yeah. Atharva, you are with us?
Yeah. I'm a bit sick right now, so I'm just following.
Fine. Okay.
Yeah.
Now, the substituent group, this is the same one that was put in the previous slide. These substituent groups are also hydrocarbons which contain only carbon and hydrogen. Okay. And this hydrocarbon substituent is called as an alkyl group.
Yeah.
You can have different substituents. We are just getting introduced to the concept of hydrocarbons. You can have groups other than carbon and hydrogen. You can have oxygen somewhere, you can have nitrogen somewhere. Those groups are called by different names. Now, if you have a substituent group that has only carbon and hydrogen, you call such a group as an alkyl group.
Yeah.
Okay. So an alkyl group can be a single carbon atom or it can have several carbon atoms. So in this particular case, it is shown that there is only a single carbon atom. You can also have alkyl groups that have several carbon atoms attached to them. Just like, for example, in this propane case, I can extend the chain like this. Alright. This can also be a substituent group. Okay. Now, an alkyl group, how do you form an alkyl? What is this group that is present here? This is an alkyl group. What is it explicitly? What is its structural formula? They give you just a carbon skeleton. What should this be?
That should be alkyl group.
How many hydrogen atoms would be attached to this substituent group?
Is that butane? That's butane.
No, I am not asking you to name the group. This I just want you to focus on the substituent group. Okay, we are not talking about the parent chain. I am just concentrating on this C. This is the substituent now,
Yeah.
right? So, how many hydrogen atoms is attached to this substituent group? Just from the structure, you can tell me. No? Three. So this,
three hydrogen
yeah,
around it. Yeah.
yeah. So this is CH3. Basically, this substituent group is CH3, and this is an alkyl group. All right. This is called as an alkyl group. So this alkyl group is formed by removing one hydrogen from the parent alkane, from the original alkane. The original alkane with one carbon atom is, what is it called as? The alkane group with one carbon atom. CH4. What is that called as?
4, right? Methane.
Methane. And you remove one carbon atom from this, you get the alkyl group CH3. So every alkyl group is formed by removing one carbon atom, one hydrogen atom from the alkane.
Does this only happen in branched chain alkynes?
Sorry?
Does this only happen in like branched chain?
Yeah, it will happen only in branched
Okay.
chain. In branched chain. In a straight chain, you don't have any substituent. Okay. So this, we'll see how the alkyl group is named. So you cannot always use the term alkyl because it is a common term. Alkane is a common term. There can be one carbon atom, there can be two, there can be n number of carbon atoms. So accordingly, the alkyl group is also named. Okay, so we look into the naming of the alkyl group. So first identify the alkane which is corresponding to the number of carbon atoms that's available in the substituent group. So what is the number of carbon atoms available in the substituent group here? In this particular case, what is the number of carbon atom?
Oh, 1.
1. Okay, what is the name corresponding to that? One carbon atom, you call that as methane, right? The original alkane is methane. So what you do is, from the methane, you remove the term ANE and add the suffix YL. So from methane, I erase ANE and add YL. So you call that as methyl.
Okay.
So the alkyl group here that is the substituent is methyl.
Okay, 1 second.
So this is the substituent carbon atom which contains one carbon atom, and its original, if it were an alkane, it would be named methane. Now since one hydrogen is removed from that, you erase ANE and add YL and call that substituent group as the methyl group. Methyl or methyl, whatever way you pronounce it.
Yeah. 1 second.
Fine, done?
Almost. 1 second.
Okay.
Alright, done.
Okay. So just going back to what we did, branched chain alkanes are alkanes that do not have that have carbon atoms that are bonded to 3 or 4 other carbon atoms, unlike 2 carbon atoms in a straight chain. Okay, and these branched chains, you identify which is the longest chain containing the largest number of carbon atoms. You call that as the parent alkane. Alright, and then To the parent alkane, at certain places you will have certain groups that are attached. That is, you remove a hydrogen atom and a certain group gets attached. So the attached group is called as a substituent. Alright, the substituent can be anything. It can be oxygen, hydrogen, not hydrogen, oxygen, nitrogen, or any other compounds. But if the substituent is a hydrocarbon, meaning it contains just carbon and hydrogen, you call that substituent as an alkyl group. And the alkyl group need not be just one carbon atom long, it can be several carbon atoms long. So we will see what that, how to name the alkyl group. So the alkyl group is named by finding out what is the original name of the alkane with so many number of carbon atoms. So in this case there is only one carbon atom in the alkyl group. So the original name of the alkane with one carbon atom is methane. So in methane, I remove the A-N-E and suffix it with YL. So methane becomes methyl. So methyl group is nothing but CH3. Alright. Suppose you have a structure like this, and imagine instead of one carbon atom you have two carbon atoms attached to this. So what will be the name of this substituent group or this alkyl group? This alkyl group has two carbon atoms. So first find the name of the alkyl group with alkane with two carbon atoms and then do the suffixing. So what is the name of the alkane with two carbon atoms?
Two carbon, that'll be ethane?
Ethane. Yes, Aditya?
Oh wait, I think is this going to be ethyl?
Yeah. So a substituent group with two carbon atoms is called as ethane. Okay. And by removing one hydrogen atom, I am making it a substituent group. So I call it as ethyl. Alright.
Wasn't ethyl used in it was like a lead gasoline or something? And I remember I think it was Thomas Midgley who created this.
Used in what? Can you come over that?
I was saying that there was I was learning there's a few in the 1930s leaded gasoline was called ethyl and Thomas Midgley he created and named it that.
Okay, so all of you got that, how to name an alkyl group. An alkyl group is a substituent group. Okay, so a branched chain alkane will contain two things. One is the parent alkane, which is the longest chain in the given branched alkane, and attached to the parent alkane will be the substituent group. Together they make the branched chain.
Alright.
Is that fine with everyone? Aditya? Yeah.
Yeah.
So that's what I told you. So if you look at what I have written here, when a substituent alkyl group is attached to a straight chain hydrocarbon, you get branches. Basically it is that. You take a straight chain, attach some substituent, you get a branched chain. The straight chain is called as the parent alkane and whatever is attached is called as the substituent. Fine? Okay.
Yep.
Now let's see. Yeah. That's all. Let's see how we will name these branched chain alkanes. If you look at straight chain alkanes, you don't have to worry about anything. You just find out the number of carbon atoms and give the names. Right? So one with 5 carbon atoms is called as pentane. The one with 6 will be called as the straight chain. What will be the name of the alkane with a 6 carbon atom? 6.
6.
Yeah. 5 means pentane, 6 means? Hexane. 7 is heptane, 8 is octane, 9 is nonane, and you go like that. Okay, that is for the straight chain. Now in branched chain, you will have the substituent groups attached at different positions, isn't it? All of them need not be attached at the same position. So if you look at this example that I am showing you, you have substituent groups that are attached at different carbon atoms. Right? All of them are not on the same carbon atom. So when you name, you will have to indicate where is the substituent attached. You will have to indicate the location of the substituent. Okay. So we will see the rule that is followed to name the branched chain alkanes. So let me take the first example of this particular alkane. Okay. Is it a branched chain or a linear chain, means straight chain? Is it a branched chain or a branched chain? Okay. So the first step is find the longest chain of carbon in the given molecule. You call that as the parent alkane. So which is the longest chain here? Let's number it. Okay. So I start from the left.
It's the one that goes it goes
4.
It's
5,
1, 2, 3, 4,
6, 7. Okay, this is one way of naming. The other way is 1, 2, 3, 4, 5 and 6, or 1, 2, 3, 4, 5, 6, or 1, 2, 3, 4, 5, 6, 7. So which one is the longest chain?
1, 2, 3, 4, 5, 6, 7.
7. So the linear one, you can take it to be the longest chain. That is the longest chain. Am I right? Yeah. So that's the longest chain. So what is the name of the parent alkane with 7 carbon atoms called? Longest chain has 7 carbon atoms. So we just told now, no? Pentane is 5, hexane is 6. So what is 7?
Septane.
Not septane, heptane. Heptane.
Heptane. Oh, I always confuse
Heptane. Okay, never mind. Alright, so the first step is to identify the longest chain of carbon atoms, and that is the parent alkane. So in this case, heptane is the parent alkane.
Yeah.
Okay, now the second point is number the carbons in the main sequence. So 7 is the main sequence, and you will have to number such that start at one end and give numbers such that the groups attached to the chain will have the smallest number. So I will erase all these numbers that I have written there. So just read the second point and tell me how do I number it. You have to give numbers. You can either start from this end or you can start from this end. But the rule is that when you start from an end and as you proceed, the substituent group should have should be bound to the least carbon atom with the least number. So if I start from here and number it 1, 2, 3, 4, 5, 6 and 7, what are the locations of the substituent atoms? Where are the substituent atoms attached? To which carbon atoms? There is one substituent here which is attached to the 4th carbon.
Yeah.
Okay. Then there is a second substituent attached to the 5th carbon. And let me explain this. Okay. And there is another substituent attached to the 6th carbon. You can name it this way. You can also use a different, you can start from the other end. You can have 7 as 1. So I mark it as 1, 2, 3, 4, 5, 6, 6 and 7. Okay. Yeah. Now what would be the number of what will be the carbon numbers for the substituents? So as I proceed this way, where is the first substituent attached to?
6.
No, I am going this way. I am using the numbering this way.
So it's attached to 2?
2. So first group is attached to 2. The second substituent is attached to 3. And the third substituent is attached to 4. Okay. These are two ways in which you can number. But the rule is that start at the end. Yeah, you listen here please. Then you can write down. Start at that end of the parent alkane such that the groups attached to the chain will have the smallest number. So which was the smallest? Is it 4, 5, 6 or 2, 3, 4?
2, 3, 4.
2, 3, 4. So you will have to have the numbering starting from this as 1. The right end will be the first carbon atom and the left end will be the 7th carbon atom. You cannot number otherwise. Okay. The rule is that the substituents will have will be attached to the least number of carbon atoms. Then the carbon atoms with the lowest number. Okay, so I have substituents placed on carbon atoms 2, 3 and 4.
Yeah.
So I have identified the parent carbon atom, and I have also located the carbon atoms where the substituents are attached. So they are attached at 2, 3 and 4. Is that fine?
Yeah.
Now moving on to the third point. Add numbers to the names of the substituent groups to identify their position on the chain. So let me erase the wrong the wrong way of numbering. So I'll erase all these things. So now this is the only way to number it. Okay. Now what I do is add numbers to the names of the substituent groups. Now first identify what are the substituent groups. There are 3 substituent groups. What is the name given to this and to this? What are the substituents? The substituents are alkyl groups, and they are formed from alkanes by removing a hydrogen atom. So the first substituent that is attached at 2 is formed from CH4, and what is that called?
Methane.
Methane, and the substituent is called as methyl.
Methyl, yeah.
Yeah, methyl or methyl, whatever. The second one is also the same, methyl. Now what is this with 2 carbon atoms called? The substituent group with 2 carbon atoms.
Oh, isn't that 5, right?
Where is it 5? There are only 2 carbon atoms. Don't count the hydrogen.
Oh, 2 carbon. Oh, my bad. Yeah, 2 carbon.
2 carbon.
That'll be ethane.
Ethane. It is ethyl. All right. So you have 2 methyl groups and 1 ethyl group. Fine. Now one of the methyl is attached to the second carbon atom. The second methyl is attached to the third carbon atom, and the ethyl group is attached to the fourth carbon atom. So now I am going to locate the carbon atoms as well as identify what is the groups attached to them. So it becomes 2 methyl, 3 ethyl, and 2 methyl, 3 methyl, and 4 ethyl. So these are the substituent groups. First I am locating where the substituents are attached. So I have found out they are located at points 2, 3 and 4. And now what is attached to 2, what is attached to 3 and what is attached to 4 should be explicitly mentioned. At 2 it is a methyl group attached, at 3 it is a methyl group, and at 4 it is an ethyl group that is attached. Does that make sense?
Yeah.
Okay. Now you look at this, you have 2 methyl appearing 2 times, right? It appears at both points 2 and 3 on carbon atoms 2 and 3. Alright. So instead of writing 2 times 2 methyl and 3 methyl, I will try to club them. So I will use prefixes to indicate the appearance of the same group more than once in the structural formula. So what is the group that appears more than once in this particular example? What is the group that appears more? You have 3 groups attached, methyl, methyl and ethyl. What is the group that appears more than once? Methyl. So I will use prefix. Instead of using methyl 2 times, I will use the prefix like di or tri. So in this case, it appears twice. So I call it as 2, 3 dimethyl. 2, 3 dimethyl, and I also have that 4 ethyl as such. Okay. So I have clubbed the methyl groups into one single term, dimethyl. So 2, 3 dimethyl indicates there is a methyl group at the point 2 and at the carbon atom 3.
Yeah.
Okay, fine. Now list the names of alkyl substituents in the alphabetic order. Okay. So when you write, you have the substituent groups like methyl, ethyl, and then if you have 3 carbon atoms, you call that as propyl and so on. So this alphabetic order is important. So list the names of the alkyl substituents in the alphabetic order, but you have to ignore the alphabetic order of the prefixes. The di, tri and all is not accounted for. Alright. So in this particular case, it is the methyl group and the ethyl group that comes. So which one comes first? Is it methyl or ethyl? Alphabetically. Ethyl comes first.
Alphabetically.
Yeah, alphabetically ethyl comes first. Even if methyl has a prefix like D and D comes before E, you will not consider the alphabetic order of the prefix. It is only the alphabetic order of the substituent. So it becomes ethyl comes first, so it is 4-ethyl and then 2,3 dimethyl.
Okay.
Alright?
Yeah.
And finally, the way to write this is, if you have numbers, yeah, so you will have to use proper punctuation. You use comma to separate the numbers. If there are numbers like 2 and 3, you use comma in between to separate them. And you use hyphen to separate numbers and words. So when it is 4-ethyl, I take 4-ethyl. 4 is a number, ethyl is a word. So I use 4-ethyl to separate a number and a word. Hyphen to separate number and word, and comma to separate between two numbers. And you write the entire name as without any space. So the final name is like this: 4-ethyl hyphen 2,3 hyphen dimethyl heptane.
Yeah.
Yes, is that fine?
Why is it like 4-ethyl, like specifically?
Ethyl is present at the 4th carbon atom, right?
Okay, that's what. Alright, I see.
4-ethyl doesn't mean there are 4 ethyl atoms. It is located at the carbon number 4. Okay. So we named it like this: 1, 2, 3, 4, 5, 6 and 7. Just redoing this once again. First you will identify the longest carbon chain. So the longest carbon chain was the one that had 7 carbon atoms.
Yeah.
Okay, that was heptane. So that would come at the end of the name. Okay, the parent carbon atom would come, parent alkane would be found at the end of the name. Now you will have to number the carbon atoms such that the substituents are attached to the least number of carbon atoms, or the lowest number of carbon atoms. So if I start naming from left to right, I will have the substituent as positions 4, 5 and 6, which is not the least. So I will have to name it from the other end. So I get substituents at the carbon atoms 2, 3 and 4. Now there are 3 substituents, one at 2 which is the methyl group, one at 3 which is again the methyl group, and one at 4 which is the ethyl group or ethyl group. Okay. So I write it as 2-methyl, 3-methyl and 4-ethyl heptane. Now since methyl appears twice, so whatever appears twice, you don't have to write it n number of times, so you use twice or thrice accordingly. So in this case methyl appears twice, so I write 2,3 dimethyl, and then you have this 4-ethyl, and the parent carbon atom is heptane, parent alkane is heptane. Now the final approach is to arrange them alphabetically. So alphabetic order does not does not apply to the prefixes like di or tri. It only applies to the substituents like methyl, ethyl, propyl, butyl and so on. So methyl comes after ethyl, so it is 4-ethyl and then 2,3 dimethyl, and the parent alkane is heptane. So that you should not leave any space in between anything. In order to distinguish between numbers and words, you use hyphens to separate words and numbers, and commas to separate numbers. Is that fine? Yeah. Okay. Now using this, let us try one example. I'll put down all these hints or the steps side by side. We can try to name them. Okay, so the first step is to find the longest chain of carbon atoms. So which is the longest chain? They may have written in different fashion, but a continuous long chain.
5.
5. So this, you say that this is 1, 2, 3, 4 and 5. Any other answer?
Could you go like from, yeah, I think that's the longest chain.
Writing CH3 at this position and writing CH3 at this position, will that make a difference?
So okay, so then the longest would be 6 then?
The longest would be 6. 1, 2, 3, 4, 5, 6. Fine?
Okay, I see. Yeah.
Yeah. So the longest chain is the one that has the largest number of carbon atoms. So this is the longest chain.
Yeah.
So the longest chain is, what is the name given to the longest chain with 6 carbon atoms?
Hexane.
Hexane. Okay, so this is the parent alkane. Alright?
Yep.
Okay.
Yep.
The next step is written here. You have to number the carbon atoms in the sequence such that the substituents will be attached to the smallest number of carbon atoms. So where you have one substituent and to which carbon atom is it attached so that it gets the smallest number. So either you start numbering from left or start numbering from right and find out in which way you will get the substituent attached to the smallest carbon atom. So if I start numbering from left, this is 1, this is the second carbon atom, this is the third, this is the fourth, fifth and sixth. Okay? And where is the substituent attached to?
The second, it's attached to the second.
This is not the substituent, Elijah. This is on the main chain. Okay, so that's the first.
Okay, so then the fourth one.
Fourth one. If I number from left to right, I get the substituent attached to the fourth carbon atom. But is this the least, or is there a different way of numbering? Why not try the other way? Start numbering from this as the first. 1, 2, 3, 4, 5, and this becomes 6. Now where is the carbon atom attached? I mean the substituent attached to? From right to left, at what position is the carbon attached? I mean, the substituent attached.
It's attached at 3.
3. So which one should you choose? Is it 4 or 3? You have to choose such that start at that. Right? Yeah, you have to use the smallest number. All right?
Yeah.
Okay. So you have. So let me erase that. So I will start numbering from this end. This is 1, 2, 3, 4, 5, and this is the 6th carbon. And I have a substituent that is attached at the 3rd carbon atom. Okay. So
yeah.
So this was hexane, and I found out the group. What is this group? The substituent group called as with 2 carbon atoms. Substituent group with 1 carbon atom is methyl. Ethane is the ethyl. Ethyl. So ethyl is the carbon. So the substituents are attached at the location 3. So in the third step, it becomes 3 ethyl. Okay.
Yep.
3 ethyl, and the parent name is hexane.
Okay, hexane. 3 ethyl hexane. Okay.
Okay. Now you have only one group that is attached, so you don't have to worry about what is the prefix or suffix needed. So it remains the same. So it is just 3 ethyl hexane. So all these, since you don't have many substituents, it remains the same. So the answer is 3 ethyl hexane.
Alright.
Is that fine?
Yep.
Yeah.
Okay.
Now just try with this one and identify, and then maybe we will wind up. Yeah, just 2 minutes, Aditya. Yeah. Now find out what is the longest chain in this case. There are several. It looks like always the representation need not be as you see. Okay, this one need not be the longest chain. Okay, don't take it like that. Find out the longest chain that has the largest number of carbon atoms. Which is that chain?
Is it 5?
How did you come with that? You came from here?
It just
the vertical one?
All the way up.
The vertical one?
Wait, it's
you can
is it 6?
Yeah. So you have
you
can have something like this. This is the longest chain that is possible with this structure. Okay. So this is hexane with the 6 carbon atoms. Okay.
Yeah.
Okay. Now number you have how many substituents attached to the main group? How many substituents? When if the one that I have encircled is the main group, what are the substituents?
There's
there?
2.
So one at this location and one at this. Okay. So you will have to number such that those two will get the least number. Okay. So either you can start from this end or you can start from this end. Give numbers such that the substituents get the least number. So if I start with 1 here, the substituents will be attached to the third carbon. Okay?
Yeah, third, yeah.
If I start from 1 here, the substituents will be attached to the fourth carbon. So which one should I choose? Third one. So I will start numbering like this. This is 1, this is 2, this is the third, fourth, fifth and sixth. Okay? Okay, now I have done that and I find that the substituents are attached to the third carbon.
Yeah.
Alright. 2 substituents, both of them are attached to the third carbon. So I'll write 3, 3. The next step, I will attach the substituent name to the number of the carbon atom. So what is the substituent attached to the third carbon atom? One of the substituent is methyl. One is 3-methyl. What is the next? The next is also attached to the third carbon atom.
It's also methyl.
And that is again 3-methyl. Both of them attached to the same carbon atom and both of them are the same group for this particular example. So 3-methyl, 3-methyl. Yeah. So the next step, instead of writing so many times, instead of to avoid repetition, you will club them. Okay. So there are 2 methyl groups. So you call them as dimethyl. Okay. And where are they attached? This is 1 methyl. This is another methyl. Both of them attached to the third carbon atom. So I will write it as 3,3 dimethyl. Okay. 3,3 dimethyl hexane. Very good. And for this particular example, you don't have any both the substituents are the same group, so you don't have to follow the alphabetical order. So I use punctuation. So this is the final name, 3,3 dimethyl hexane without a space.
Yeah. Okay.
Without space in between them. Okay. So it's easy if you find out what is the parent alkane. So you will have to use your creativity to find out which is the longest chain. That's all. The one that is shown straight need not be the longest chain. Is that fine?
Yeah.
Yeah. Okay. So I think I'll stop with this. Hope this is clear. There is another example that's given. You can try doing that. Okay, at home. So can we wind up? Any doubts?
Yep. No.
Yeah. No. Thank you. Thank you for joining.
Thank you.
Bye.
Bye.
Bye.